Okay, so welcome back. So this is the fourth lecture for chapter 22, graph. And in this lecture, we are going to cover the undirected graph. Okay, and here we only have three files: vertex file and the undirected graph class and the application. So we don't have the edge class. So let's take a look at the vertex file. For the vertex class, as usual, we have the ID and the label and the constructor toString and the equal hash code. Okay, not a lot of difference. And we don't have edge class. So for undirected graph, what over here is we use the vertex adjacent list to represent the relationship. Okay, so here you have a vertex and then its adjacent vertex list. Okay, and we represent it using the map. And this time for the map, the key is vertex. So this is the key, and this is the value part. And the value is a list of vertex instead of list of edge. Okay. Then we call it adjacent vertices. Okay. And we have all the vertices stored in the array of vertex and a number of vertex, a number of edges. Okay, so that's the instance variables for the undirected graph. Then we have the constructor, so create an empty hash map and an array. And we have the number of vertex and edges returned, and all of the vertices returned in the vertex array. And we add a vertex, so we add it to the array at the same time. If the vertex is not exist in that map, we are going to add it and also empty array list. And for the add edge, okay, what we are going to do is first to check if U is in the map, that vertex adjacent list, okay. If it is not, then we are going to add it, and it's array list, same thing for the V, okay. After it, we check if vertex U as key, and we try to get its value. So that's the list of vertices, list of vertex, okay? And if V is contained with it, then we are going to, or if it's not in that list, so if not in the list, then you're going to add this vertex to the list. Okay, so same thing for if V, vertex V is the key, and you get its list. Okay, and if it's not, you're going to add it to the list. Okay, so that's to add the edge, because once you know the neighbor vertex, basically you also know the edge. And here it's just for the vertex, you try to get all of its neighbor and store it in a set, okay? And similar, okay, so we just use the hash set and try to add it. And to check if two vertex are adjacent to each other. First, you check if both of the vertex is either one. If it's not in the vertex map, then return false. Is that? And if it is, like if U is in it, and then check if V also in it. If V in its neighbor list, yes, then it's adjacent. Is that? Or you can check if V's neighbor is U. Okay. That's for the adjacency check. And the last is just the output for the graph. And this is a driver part. It's pretty similar. Use the G1 graph for the friendship. Okay. And then what we are going to check is check the graph and specify pair of vertex if they are neighbor, and also try to find a vertex neighbor. Same thing for the graph G2. Okay. And we are going to run it to see the output. So here's the output of this example. You can see it's pretty much like our first example. Okay, yeah, but this version is undirected. Okay, so that's for this lecture. Okay.